Hello everyone, I am Amit Maru and today in this video we will discuss about C program for a binary search algorithm. Binary search algorithm is algorithm of a divide and conquer method. So before starting off this video, I am requesting to all, please watch my video on binary search algorithm. The link is available in description. So watch that video first and then watch our today's video on C program for binary search algorithm. Before starting to implement our binary search in a C language, let us first understand the concept of binary search with one example. One thing you have to note it down here, that is in our binary search, your input must be in ascending order. Whenever the input is in ascending order, then and then we can apply our binary search to search element from the list of number. So the basic purpose of binary search algorithm is to search any number from the large list of number. So for example, we have a list of number like -5, -2, 0, 3, 8, 8, 9, 12, 20, 26 and 31. These all are the different elements and these elements are in ascending order. As we discussed, it must be in ascending order, then and then we can apply our binary search algorithm. This is the list of number and we want to search whether this 12 is available in this list or not. If it is available, then we have to identify the index number. So 12 is available on index number 8. So your algorithm will return index number 8. It means that your 12 is available and it is available on index number 8. So let us discuss how your binary search algorithm can identify the index number, or we can say the position of our number from the list. So in this list of number, we have to identify our searching element, that is x is equal to 12. As per the binary search algorithm, the first step is we have to take a two variable. One is I and second one is j. I is nothing but the index of our first element, that is 1, and the j is nothing but the index of our last element, that is 11 in our case. Now the next step is we have to identify the middle element, or we can say the index of middle element. So how we can find the index of middle element? We have to perform operation like I plus j divided by 2. So I is equal to 1, j is equal to 11. So 1 plus 11 is equal to 12. 12 divided by 2, that is 6. So the middle element will be 6. So this is nothing but the k is equal to 6. Right? So k is nothing but the index of our middle element. Right? So I is our first index of first element, j is the index of last element, and k is the index of middle element. Now the first step is we have to compare our searching element with the middle element. Our middle element is 8 and index is 6. So we have to compare our searching element with our middle element. If your searching element is less than or is equal to middle element, it means that our element will be available inside the left part. If it is greater than the middle element, it means that our searching element will be available inside the right part. So from the very first step, we can save half of the time. Either we have to search in left part or we have to search in right part. Right? So suppose let us take this example. Suppose x is equal to 12. So we have to compare 12 with our 8. Right? So we have to compare x less than or is equal to t of k or not. If x is our such a element, it means that 12. So 12 is less than or is equal to 8 or not. So we have to compare 12 with our middle element 8. If 12 is less than or is equal to 8, it means that our 12 is available inside the left part. But 12 is not less than or is equal to 8. This condition is false. It means that our 12 is available in right part. So that we have to just ignore this part. We are not searching our element inside the left part. It means that we have to just search our element inside the right part. Now we have to perform same operation. We have to take I variable is the index of our first element and j is the index of last element. Now our first element will be 9 and the index is 7. So I is equal to k plus 1. So here the value of I will be k plus 1. K plus 1 means what? 6 plus 1, 7. So I will be 7. and j as it is. So j is equal to 11. Now we have to again identify the value of k. I plus j, that is 7 plus 11, 18. 18 divided by 2, that is 9. So we have to identify middle element, that is 9. This is, and 20 is our middle element. Now again we have to compare our searching element 12 with this 20. If searching element is less than or is equal to 20, 12 is less than or is equal to 20. If yes, then it will be in left part, otherwise in right part. So 12 is less than or is equal to 20. This condition is true. It means that our element will be available in our left part. So now we will not search in our right part. Again we have to identify index of first element and index of last element. It is known as I and j. So now whenever it is in left part, at that time I will be as it is and j is equal to k. So we have to store the value of k inside the j. So j is equal to 9 and I as it is, that is 7. Again we have to identify the middle element, or we can say the index of middle element, by using equation that is I plus j, that is 7 plus 9 is equal to 16. 16 divided by 2, that is 8. So the k is equal to 8, right? And the middle element is 12. Now again we have to compare our 12 less than or is equal to 12 or not. 12 is a searching element and our middle element is 12. So we have to compare with the 12. 12 is less than or is equal to 12. Yes, this condition is true. It means that our element will be available in our left part. So whenever it is in left part, then I will be as it is and the value of j will be k. So I will be I is 7 and j is equal to 8. And again we have to identify the value of k. 7 plus 8 is equal to 15. 15 divided by 2, that is 7.5. So in integer it is 7. So the value of k is equal to 7. Again we have to check the 12 with, we have to compare 12 with 9. So 12 is less than or is equal to 9. This condition is false. It means that it is available in right part. So whenever it is in right part, then the value of I will be I is equal to k plus 1. So k plus 1 means what? 8. So I is equal to k plus 1. So I will be on location 8 and j 8 as it is. So j is also on same location. So whenever the value of I and j both are equal, then we have to stop. When the value of I and j both are equal, at that time we have to stop and we have to return the value of I. Now the value of I is equal to 8. It means that our element 12 is available on location number 8, or we can say the index number 8. This is all about binary search algorithm. Every time we have to ignore one part, that is either left part or right part, so we can save maximum time, and the time complexity of this algorithm is order of log n. It is far better as compared to our sequential search algorithm. This is the simple algorithm. In this algorithm we have to call binary search algorithm, and we have to pass our list of element and searching element as an argument. Whenever the value of I and j both are equal, then we have to return I. Here value of I and j both are equal, so that we have written I, and I is equal to 8. So whenever I and j both are equal, then we have to return I. Otherwise we have to perform I plus j divided by 2, and we have to identify the middle element, that is k. So as we already discussed, every time we have to identify the middle element by using equation I plus j divided by 2. And we have to call same function. This is the function call itself, that is a recursion. If x less than or is equal to t of k, whenever this condition is true, at that time we have to search in our left part, and when we search in left part, at that time I as it is and the j will be k. Whenever this condition is false, then in else part, it means that we have to search in right part. So whenever when we search in right part, at that time value of I will be k plus 1 and j as it is, and searching element we have to pass as argument. This is all about binary search algorithm. So let us implement this algorithm by using C programming language. So as per the C programming language, we have to include various header file. For example, a standard input output header file, because we are using some input output function in our program, which is available in our system library inside the standard input output header file. Another header file, that is conio.h, that is console input output header file, we have to include by using preprocessor directive like has include. And this console input output header file we are including because in our program we are using two functions. One is a clear screen and the second one is getch. Both these functions available inside our conio.header file. So we have to include this both the header file before starting of our program. Now the first step is we have to declare our first function, that is void main. This is our main function. In that inside this main function we have a two part. One is declaration part. In that we have to declare different variables in array. For example, t is a array which has a size of 50. I, key, x, and j, these are the different variables we are declaring in our declaration part. Another thing is in our program we are going to call one function, that is binary search function. So before calling this function we have to declare, it is also known as a prototyping of the function. So prototyping is nothing but declaration of function. So in declaration part we have to declare our function, that is binary search function. Now in our executable part, our first step is we have to clear our screen so that we can easily see output of our program. So clear screen, which is available in our console input output header file. Now the next step is we have to ask to our user about how many element they want to enter, and then we have to use one scanf function to scan the value which is entered by our user. So scanf %d ampersand of n. Then based on this value of n, we have to take one loop. This loop will be executed n times because we want to enter different values inside our array. So this loop will be executed n times and will store different values inside our array by using scanf function, scanf %d ampersand of d of a. So this all the value will be stored inside our array capital T. Once we enter all the values from the user, then we have to display on the output screen. So again we have to take one for loop, and using this for loop we have to print all the values. This loop will be again executed n times, and by using printf function we will print all the values which is stored by the user. This all the values will be displayed on our output screen. So by using printf function like a printf %d a, this is nothing but the index number, and t of a will be the value. So these all the values including index will be displayed on the output screen, and this loop will be executed n times. So we'll display all the values including index number. Then we have to print one message, that is printf searching element, and we have to ask the user enter searching element. Our user will enter any element, and this element will be stored inside our key. So key is nothing but we are going to search this key value from the large list of number. This is our searching element. Now as we discussed, we have to consider index of our first element is I. So I is equal to 1, this is the index of our first element, and j is equal to n, this is the index of our last element. So I is the index of our first element, j is the index of our last element. Now we have to call this function, that is binary search, and we have to pass our whole array capital T as argument. I is the index of first element, j is the index of last element, and key which is going to be searched in our large list of number. Then we have to print the index number, that is index is equal to %d x. So this function will return index number where our searching element is available, and this index number will print here. And then our last statement, that is getch, and then we have to close our main function. Now when we call this binary search function, at that time we'll jump on a body of the function. So our body of the function is available outside our void main. Inside the body of the function, as we already discussed, we have passed a whole array as argument I, j. There is the index of first and last element, and searching element, that is our key that we have to pass. And to receive this all the values, we have to declare one array and different variable like I, j, and key. These will are the local variable of our binary search algorithm. Inside the binary search algorithm, the first step is we have to declare different variable, for example integer k. Then, as we already discussed, we have to check the value of I and j both are equal or not. Whenever both are equal, at that time we have to return value, that is value of I. This is nothing but our index number where our searching element is available. So the first step is we have to verify value of I and j both are equal or not. Whenever both are not equal, at that time, as we already discussed, we have to perform operation like I plus j divided by 2, and using that we can identify the middle element. So k is equal to I plus j divided by 2. So k is nothing but our middle element. So we have to identify middle element. Once we get middle element, then we have to check whether the value of middle element is less than or greater than or is equal to key or not. Or we can say the value of key is less than or is equal to t of k or not. If the middle element, or we can say the searching element, is less than or is equal to the middle element, it means that it is available in our left part. Whenever it is available in left part, then the value of I will be as it is, and the value of j we have to change, that is j is equal to k. So the value of j will be j is equal to k and I as it is. It means that our element is available in our left part. Then we have to call same function to search our element in our left part, and we have to pass I and j both as argument, and key we have to pass as a argument. When this condition is false, it means that this key is not less than or is equal to t of k. It means that our element is available in our right part. Whenever it is in right part, as we already discussed, then we have to search in right part, and the value of I and j will be different. Now the value of j will be as it is, and the new value of I will be I is equal to k plus 1. Now the value of I will be k plus 1 and the value of j will be as it is. It means that our element is available in right part. So we have to search in right parts. Again, we have to pass this different argument like a whole array as a argument. I is nothing but k plus 1, j as it is, and searching key we have to pass as argument. So we'll check our element in a right parts. So in this way we have to check every time by using recursion function. We have to check left part in our left part or right part, and once the value of I and j both are equal, at that time this function will return value of I, and then we have to just print the value of index, that is x, because this value or return value of I will be stored inside the x, and this value of x will be displayed by using this message index is equal to the value, so that we can get index number where our element is available in the list. So this is all about binary search algorithm. So let us check output of the program. So we are just running the program. So the first step is we have to ask to our user about different number of elements. Suppose our user entered 7. It means that we have to store 7 different number inside the array. For example, 5, 6, then 9. As we discuss, we have to enter number in ascending only. Then and then we can apply our binary search. 25. Then for example 34. Then after, for example, 80. So 7 number we have entered, And as we already displayed the value including index number, so 5 is available on index number 1, 6 is available on index number 2, 9 is available on index number 3, 10 is available on index number 4, 25 is available on index number 5, 34 on 6, and 80 on index number 7. And these all the numbers are in ascending order. So your input must be in ascending order. Now if you want to search any element, for example if you want to search 25, so enter searching element, for example 25. So your program will return index number, and the index number is 5. It means that 25 is available on index number 5. So this is correct, 25 is already available on index number 5. So this is all about binary search algorithm. So thank you very much for watching this video.